Today we're going to be working on Leetcode question number 111, 111. It says minimum depth of binary tree. Given a binary tree, find its minimum depth. The minimum depth is the uh, number of the nodes along the shortest path to the root node down to the nearest leaf node. And the definition of the leaf node is that it's the node with no children. So over here, the output is gonna be 2 uh, because the minimum depth is the number of the nodes from it's gonna start from here from the root node to the smallest one to the closest leaf node, and that is 9. So the minimum depth is just like 2. So we can just do it in a depth first search method. So basically they are counting, the reason it's 2 is because they are counting the root node. So that's what we're gonna be doing. Okay, so we're gonna be doing it using a recursive approach, and all we're gonna be saying is like, if you don't have, like, the root is basically none. So if no root, if not root, meaning it's none, we're gonna be returning 0. And if we have reached on the leaf, meaning it does not have a left node and a right node, we're gonna be returning 1, because that's the where we're gonna be starting. So if not uh, root dot left and root dot right, sorry, and not root dot right, if both of them doesn't exist, both of them don't exist, we're going to be returning 1. Now if one of them does exist, right, so what we're going to be doing is like, we're going to say that if the root dot left does exist, right, and the root dot right does not exist, and not root dot right, so all we have to do is to call 1 plus, because the root dot left exists, we need to calculate uh, the minimum the minimum height of the left side. So we're going to be calling root dot left. Similarly, we're going to do the same thing for the right one, that if not root dot left but root dot right does exist, in that case we're going to be returning 1 plus, we're going to call this recursively, we're going to call this function minimum depth with root dot right. Okay, and finally, like, when finally if both of them exist, right, so then in that case we're going to be calling that return plus 1, whichever is the minimum of whenever I recursively call these functions for the left node and the right node, whichever is the minimum, that's going to be added to 1. So we have this self dot men depth root dot left and self dot men depth root dot right. Yes. Let's see how it does for the other test cases. Oh, we got an issue here. Global name minimum depth is not defined. Oops. There's a typo here. Basically, self dot minimum depth. Yes. And it passed all the test cases.